This lesson is on different number types. The first number type is called natural numbers. Natural numbers are numbers that you learned as a child when you first learned how to count. So for example, 1, 2, 3, 4, 5, and large numbers, which we're going to call infinity. The second number type is called whole numbers. Whole numbers are similar to natural numbers, except it also includes the number 0. So we have a 0, 1, 2, 3, 4, 5, and large numbers, which we're going to call infinity. The third number type is called integers. Integers are similar to natural numbers and whole numbers, except it also includes negative numbers. So for example, we have is -5, -4, -3, -2, -1, and now 0, which was the whole numbers, and then 1, which we started for the natural numbers, 2, 3, 4, 5, and large numbers, which we're going to call infinity. The fourth number is called rational numbers. Rational numbers are fractions where A is a numerator and B is a denominator, and the B cannot equal to 0. So a number, for example, 4 is technically a rational number because it's really 4 over 1. We can also use the number 8 over 2, which are positive numbers. Those are considered rational numbers. And also -8 over -2. You can use integer numbers for rational numbers. The next number is called prime numbers. Prime numbers have only two factors, the number 1 and the number itself. So for example, 2. 1 times 2 is 2. That's a prime number. 3. 1 times 3 is a prime number. There is no other number that can be multiplied to make a number 3 or multiples of 3. 5. 1 times 5 is a prime number. There are other numbers, for example, 7, 11, 13, 17, 19, 23, 29, 31, and there's obviously more numbers. The last number type is the composite numbers. Composite numbers have more than two factors, and every composite number can be written as a unique product of primes. For example, we have is 4. 4 can be written as 1 times 4 and 2 times 2. The number 8 can be written as 1 times 8 is 8 and 2 times 4. The number 12 can be written as 1 times 12 and 2 times 6 and also 3 times 4. So some of these composite numbers have multiple different factors. So now using the prime number ideas, we're going to go ahead and we're going to do prime factorization. So for example, like the number 36, using an inverted factor ladder, we're going to list out all the prime numbers for 36. So we're going to use an inverted factor ladder, which looks something like this, and it's a division symbol that is upside down. So you want to make sure you have a number, a prime number out here that goes into 36. So as we mentioned of prime numbers, you may want to start with number 2 because 1 is not a prime number, nor is it a composite number. So you want to start with the lowest number, which is 2. Does 2 go into 36? Now if it doesn't, you can use other prime numbers. So in this case, 2 goes into 36, but also 3 as well. So it doesn't matter which one you start with. You can start with a 2 or you can start with a 3, as long as you start with the lowest prime number. So in this case, I'm going to go ahead and start with a 2. 2 goes into 36 18 times. Now 18, is that a prime number? No, because it can be other numbers or factors as well. So we're going to go ahead and divide it out. And again, I can choose 2 or 3, but I'm going to go ahead and choose 2. So 2 goes into 18 9 times. Now is 9 a prime number? No. So we're going to go ahead and try another number. 2 does not go into 9, so the closest prime number that we can use is 3. So we're going to say 3 goes into 9 3 times. The last number 3 right there, this right here, is a prime number. So since that's a prime number, you know then to stop for your factorization. So we're going to go ahead and list out all the prime numbers. So multiples of 36, the prime numbers are 2 times 2 times 3 times 3. We try to list out these numbers right here from the smallest to the largest right there. Okay, let's try another one. 48. 48 can be divided by a prime number 2. So 2 goes into 48 24 times. 24 is not a prime number. So we can try again. 24. We can use 2 again. 2 goes into 24 12 times. 12 is not a prime number, so we keep going. What else can go into 12? So 12 you can use again is 2 or 3. Since both are small prime numbers, you can use that. But I'm going to go ahead and try 3 this time. So 3 goes into 12 4 times. 4 is not a prime number, so we're going to try another number. The smallest prime number we can choose is 2. So 2 goes into 4 2 times. Now that last 2 right there on the bottom, this is a prime number, so then we know to stop this problem right here. So we're going to go ahead and list out all the prime factorization of 48. So 48 is 2 times 2 times 2 times 2 times 3. We have is 1, 2, 3, 4 2's, which came from here. 1, 2, 3, 4 2's, and then the 1, 3 right there. Okay? Last example, 110. So we're thinking is what is the smallest prime number that will go into 110? So if it ends in a 0, you can either use a 2 or you can use a 5. So I'm going to go ahead and use 2. So 2 goes into 110 55 times. 55 is not a prime number, so we're going to try again. So 3 does not go into 55. I think the next prime number we can use is 5. So 5 goes into 55 11 times. 11 is a prime number down here. So since this is a prime number, I know then to stop my prime factorization. So now we're going to go ahead and list out 110. So 110 is 2, right? From this 2 right here. 5 goes right here. And 11 right here. So to check your work, you can always multiply all of these numbers together, and that should give us this answer right here. Okay? So that is the lesson for today.